Good morning, students. 12th English medium physics. Topic current electricity. We will see some more MCQs. Okay. First, two different conductors have same resistance at 0 degree Celsius. It is found that resistance of first conductor at T1 degree Celsius equal to resistance of second conductor at T2 degree Celsius. The ratio of temperature coefficient for two conductors is given. You have to find, okay? So, first of all, out of this data, you have to identify which equation you have to use. Okay, yes, we have to use this equation, that is R is equal to, it is R theta is equal to it, or you can say R only, okay. R is equal to, it is R0 1 plus alpha theta minus theta 0, where this theta 0 is called reference temperature. R0 is resistance at this reference temperature. R is resistance at this given temperature. Now you are given two different conductors have same resistance at 0 degree Celsius. So I am taking theta 0 is equal to 0 degree Celsius. Clear about this? Okay, then this equation reduces to, here it is, R is equal to R0 1 plus alpha theta. Clear about this? Okay. Now for first resistor, for first conductor, I can write this equation. Okay, K for first conductor at T1 degree Celsius, its resistance, I am assuming K is R1, so I can write it is R1 R0 1 plus alpha 1 T1. Any doubt? Okay, for second, I can write R2 is equal to R0 1 plus alpha 2 T2. Why R0 same? Because you are given okay, two different conductors have same resistance at 0 degree Celsius. Yes, this resistance is at reference temperature. So yes, this resistance, okay, means this R0 is same for both conductors. Okay, so now if they are equal means you can compare this to equation. Okay, now R1 is equal to R2. So therefore R0 1 plus alpha 1 T1 is equal to R0 1 plus alpha 2 T2. R0 cut. Okay, so it is 1 plus alpha 1 T1 is equal to 1 plus alpha 2 T2. 1 also cut. So alpha 1 T1 is equal to alpha 2 T2. And therefore alpha 1 upon alpha 2 is equal to, it is T2 upon T1 degree Celsius. Clear? Okay. What is ratio of coefficient, temperature coefficient? What is ratio of temperature coefficient? Alpha 1 upon alpha 2 is equal to, it is T2 upon T1. Yes, it is simple. Clear about this? Okay. Chalo. Now the next question. What is the next question? Next question is masses of three wires of copper are in ratio of 1:3:5 and their lengths are in ratio of 5:3:1. The ratio of electrical resistances are. You have to find ratio of resistance. So yes, first of all, you know what is equation of resistance, that is R is equal to rho L upon A. What is equation of resistance? Yes, R is equal to rho L upon A. Rho L upon A. Okay, rho, that is resistivity actually. Okay, rho is resistivity, L is length, and A is cross-sectional area. Here you are given data in terms of or with respect to mass and length. Here it is resistivity. For three wires of copper, resistivity is same, so constant. L, yes, you are given data about L, but you are not given data about A. You are given data about mass. So you have to convert this equation with respect to mass. How to convert? See, is equal to rho L upon A. I can multiply and divide by A. Any doubt? Okay. So is equal to, it is rho L square A into L, cross sectional area into length, means it is volume. Now you know one relation. Okay. Okay. Density is equal to density I have to indicate by D. Density D is equal to mass upon volume. So volume is equal to, it is mass upon density. Okay. So here I can write this equation as rho L square. V, I can replace this V by M upon D. M upon D, where D is density. So yes, here you have to write, okay, here rho and D, they both are constant. They both are constant. So I can write, therefore R is proportional to L square upon M. R is proportional to L square upon M. So it is relation between resistance of conductor, length of conductor and mass of conductor. Clear about this? Okay, R is proportional to L square upon M. R is proportional to L square upon M. Now see, you are given data of masses and lengths. Then yes, how to write a relation? Okay, R1 is to R2 is to R3 is equal to L1 square upon M1 is to L2 square upon M2 is equal raised to L3 square M3. Okay, and yes, you are given data. See, chalo, length, for length it is for length it is 5 is to 3 is to 1. So it is 5 square. Here it is 3 square, here it is 1 square. And about mass, so it is 1 is to 3 is to 5. So 1 is to 3 is to 5. Any doubt? So here it is 5 into 2, 5 square means it is 25 is to 3 cut, so it is 3 is to, it is 1 divided by 5. Now if you multiply this by 5, then what happens? 25 into 5 is 125. 5 into 3 is 15. And 1 upon 5 into 5 means it is 1. So your answer is 125 is to 15 is to 1. And it is your answer. Clear? So from given data, first of all, you have to make relation. Okay, how resistance depends on length and mass. How resistance depends on mass and length. Clear about this? So yes, it is one easy question. Okay, sure. Now next question. So what is the next question we will see? Okay, see, carbon resistor has 3 orange bands. The maximum resistance offered by the resistor will be, the maximum value of resistance offered by resistor will be. Say you are given 3 carbon resistor has 3 orange bands. Actually, if you are given 3 orange bands, okay, orange and orange. So this fourth one is, you can say it is no color. You can say it is no color. If in table you observe for orange color, so yes, value is, yes, for first band it is resistance, I have to write like this, R is equal to, it is 3, for orange it is 3 into multiplier it is 10 raised to 3 and plus or minus, no color means error or tolerance is, it is 20%. It is 20%. So yes, you know okay how to write this. You know okay how to write this. Yes, I can also write this as it is 33 kilo ohm plus or minus 20%. Okay. Now as you have to find maximum value of resistance. Maximum value of resistance means you have to consider okay, R maximum is equal to 33 plus 20% kilo ohm. Clear about this? Only plus because you have to find maximum value. If you are asked to find minimum value, then you have to consider minus. Clear about this? Now 33 plus 20% kilo, 33 plus 20%. You have to find 20% of 33. Okay, 20% of 33 means it is 20 into 33 divided by it is 100. Divided by it is 100. So yes, it is easy actually. Okay, 0 cut, 0 cut, 33 into 2, so it is 66 divided by 10 means it is 6.6. Means it is 6.6. So is equal to, you can write it is 33 plus 6.6 kilo ohm. Okay, kilo ohm. So is equal to, it is 39.6 kilo. It is 39.6 kilo ohm. Clear? Yes, you can calculate it without calculator. Clear about this? Okay, so yes, there are some questions. Okay, yes, see, there are 3 questions with different equations with different concept. Okay, that you have to remember. Okay, first of all, you have to use this equation R is equal to R0 1 plus alpha theta minus theta 0. Then equation of resistance. Then again equation of resistance, but for carbon resistor. Clear? Okay, so yes, is how to solve some MCQs. We will see some more MCQs. First of all, write down it. Okay. Now next question. See, 2 wires of resistance is R1 and R2 have temperature coefficient alpha 1 and alpha 2 respectively. They are joined in series. The effective temperature coefficient of a resistance is, understand question, you are given 2 resistors, okay, having resistances R1 and R2 and they are connected in series. So for that series connection, you have to find equivalent temperature coefficient of resistance. See, we have equation that is R theta is equal to R theta 0 1 plus alpha theta minus theta 0. And yes, okay, R theta 0, that is resistance at temperature theta 0. R theta, it is resistance at temperature alpha theta, and alpha is temperature coefficient. Okay, now you are given the 2 wires of resistances R1 and R2. Okay, so I am assuming, okay, at time t, okay, at time t, at temperature t, for given 2 resistors. How to write equation? So yes, theta is replaced by at temperature T, but for first, so it is RT1 is equal to, it is R1 1 plus alpha 1, here it is theta minus theta 0. Here I have to write, okay, it is 1 plus alpha theta minus theta 0. So how to write temperature? I have to assume, yes, it is T. I have to assume the temperature is T, okay, and yes, theta 0, that is reference temperature. Theta 0 is called, it is reference temperature, okay. Then how to write for this reference temperature? As you are not given any reference temperature, you have to consider a reference temperature is 0. So here I have to write 0. Then it becomes, it is R1 1 plus, it is alpha 1 T. Clear about this? Okay, and similarly RT, resistance of second wire at temperature T for 2, okay, it is R2 1 plus alpha 2 T minus 0. I am assuming, okay, so is equal to, it is R2 1 plus alpha 2 into T. Clear about this? So see, it is firm. It is firm. Okay, RT1 is equal to R1 1 plus alpha 1 T. RT2 is equal to R2 1 plus alpha 2 T. And now as they are connected in series, so RS is equal to, it is RT1 plus RT is equal to, if I add both this equation, then what happens? So see, here it is R1 plus R1 alpha 1t plus R2 plus R2 alpha 2t. So I can write this equation as it is R1 plus R2 plus R1 alpha 1 plus R2 alpha 2 into t. Any doubt? Okay, so now if I am taking R1 plus R2 as common, the whole term R1 plus R2 as common, okay, so in bracket I will have, as this whole term is common, it is 1 plus, yes, I am making two groups actually, okay, so R1 plus R2 common, then it is 1 plus, here it is R1 alpha 1 plus R2 alpha 2 divided by R1 plus R2, and here it is into T, here it is RS. Here it is RS, that is for series connection. Now see, observe equations. RT1 is equal to R1, 1 plus alpha 1t. RT2, R2, 1 plus alpha 2t. For series connection, RS is equal to R1 plus R2, 1 plus this whole term into t. See, for first resistor, only resistance R1. For second resistance, only resistance R2. Then form 1, 1 plus plus temperature coefficient and into time. So here for series connection we know that, okay, total resistance it is R1 plus R2, 1 plus, then this whole term you can say it is temperature coefficient, okay, alpha for series connection, that is R1 alpha plus R2 alpha 2 divided by here it is R1 plus alpha divided by here it is R1 plus alpha. Clear about this? So yes, to solve some questions, you have to assume the reference temperature you have to consider 0 degrees Celsius. Okay, in this question actually you are not given, but you can assume. Okay, you can assume. Clear? So yes, it is one question that you have to remember. Okay. Okay. Now see, in this question, if you are given at 0 degrees Celsius, the temperatures are same, means R1 and R2 are same. Then if R1 and R2 are same, then what happens? Okay, if R1 and R2 are same, it is additional information. Okay, if R1 is equal to R2, then R1 is equal to R2. Here it is R1 plus R2. Then what happens? So yes, it is alpha for series connection. It will become alpha 1 plus alpha 2 divided by 2. Alpha 1 plus alpha 2 divided by 2. So that thing you have to remember. Okay, the alpha s is equal to this one. Clear about this? Okay, so yes, it is one question which is based on series connection of two resistors, but you have to find, okay, what is equivalent temperature coefficient. Okay, now next question. A wire of resistor R is bent into a circular ring of radius R, small r, okay, into a ring of radius small r. Equivalent resistance between 2 points x and y on its circumference when angle x or y is alpha. See, a wire of resistor R, it is one wire having resistance R, is bent into a circular ring of radius R. So what happens? If resistance of wire is R, then resistance of ring is also R. If resistance of wire is equal to resistance of ring and is equal to it is R. Now, what is length of ring? If its radius is R, okay, length of ring is equal to nothing but 2 pi r. So first of all, I have to find one thing, that is resistance per unit length of ring. Resistance per unit length of ring. That resistance per unit length of ring. Resistance per unit length of ring. Okay, I am indicating by x. X is given here. So resistance per unit length I am indicating by D. Then D is equal to what happens? Resistance per unit length means it is R upon 2 pi r. Means it is R upon 2 pi r. So yes, resistance per unit length of ring D is equal to is R upon 2 pi r. Now see, it is point X, it is point Y. You have to find what is equivalent resistance between point X and Y. So see, between point X and Y, there are two parts of ring. First, XWY, smaller one, and then XZY. Then XZY. So first of all, you have to find resistances of these two parts, because these two parts have common ends. XWY, two ends, X and Y. For this big one, two ends, X and Y, means they are in parallel connection. So first of all, you have to find resistance of these parts. Okay, the resistance of XWY. XWY means the smaller one. So R1 is equal to. See, this XWY substance angle alpha at origin, at center, okay, at center, it substance angle alpha. So yes, you know one definition, that is angle is equal to arc upon radius. So arc is equal to angle into radius. Yes, arc is equal to angle into radius. And what is meaning of resistance per unit length? Okay, what is length of this XWY? What is length of this XWY? Yes, you can say it is alpha into R. Yes, its length, this length is, it is alpha into R. Okay, so yes, if unit length is there, resistance is D. Then for length, alpha R, what is resistance? It is, okay, alpha R into D. So you can write it is alpha R into R upon 2 pi R. R cut. So it is alpha R upon, here it is 2 pi. Any doubt? Similarly, for this XZY, resistance of XZY, resistance of XZY, R2. Again, what is meaning of resistance per unit length? If resistance per unit length is D, then for any length, how to find resistance? Okay, length into D. Length into D. So here, what is length of this XZY? See, as this angle is alpha, we know that this XZY angle is 2 pi minus alpha. So what is length of this XZY? Yes, it is 2 pi minus alpha into R. 2 pi minus alpha into R. So its length is, it is 2 pi minus alpha into R, and into here it is D. So it is 2 pi minus alpha into R. Here it is R upon 2 pi R cut. So is equal to, it is 2 pi minus alpha into R divided by 2 pi. So it is how to find R1 and R2. Now, as the two have common ends, okay, then R1 and R2, they are in parallel connection. Then RP, we know its equation, R1 R2 upon R1 plus R. Right or wrong? Hello? Right or wrong? Yes, it is right. Okay. R1 R2 upon, here it is R1 plus R2. And therefore, RP is equal to, R1, here it is alpha R upon 2 pi plus, here it is 2 pi minus alpha into R divided by, into, here it is into, and divided by, here it is alpha R upon 2 pi plus 2 pi minus alpha into R divided by 2 pi. Okay, then is equal to this term as it is, alpha R upon 2 pi, okay, into, here it is 2 pi minus R minus alpha into R divided by 2 pi, divided by, see, base same, then you can directly add numerator, that is alpha R plus 2 pi R, it is 2 pi R minus alpha R, any doubt? And divided by, here it is 2 pi, so 1 2 pi cut, 1 2 pi cut, this alpha R cut, this alpha R cut, okay, then remaining terms are, is equal to, it is alpha R, this one, 2 pi minus alpha into R divided by this 2 pi, okay, and this 2 pi R. So this R cut, this R cut. Any doubt? Okay, so yes is equal to, it is alpha R, this alpha R, divided by 2 pi into 2 pi means it is 4 pi square, and here it is 2 pi minus alpha. 2 pi minus alpha. Clear? Whew. So yes, it is one MCQ actually. Okay, yes, it is one MCQ. Clear? So it is alpha r upon 4 pi square 2 pi minus alpha. That is your answer. Clear about this? So yes, it is how to solve some questions. Okay, some MCQs. Okay, yes, some MCQ. See, as I have to explain, I have to write in detail. But whenever you do solve MCQs, you have to write roughly. Okay, clear about this? Clear about this? Okay, so yes, 5 questions for today's lecture. This is it for today. Next questions in next lecture.